will start in 5 minutes. So we'll start with the session. Uh, I'm Shreyas and I'll be conducting the 8th session for CodeCrafts, and the topic is how STL works. I hope you can see the screen. So what is STL? STL is the standard template library, and it is a set of C++ template classes which have a lot of data structures, functions such as stacks, lists, arrays. It has container classes, algorithms, iterators. Basically, it contains all the things which make life for us coders easy. It has libraries like Python, which helps us keep the code short and perform operations effectively. So, basic understanding of templates is required for the working of STL. Uh, Last session was based on STL. We'll briefly revise templates. So templates are usually expanded at compiler times, and you can see how it works here. So basically during compiler time, the following code is generated, and then the compiler uses this for various types of parameters that are used in the functions. I hope that is clear. Okay. So why do we use STL? So STL has a lot of reusability. It has a lot of generic code which can be reused multiple times, and it can use the same code for different types of operations for different types of parameters, like you saw here. It has efficient algorithms, and they are much faster compared to custom code because they have been made standard and they have been checked over and over for making them completely efficient. So it also improves code readability because it is standard, right? So once you know that it is standard, then you can just look at the code and understand the functions. And since it is widely used, it is recognized by everyone and everyone understands it. So that's basically why we use STL. So we'll cover the components of STL. Basically, it contains containers, algorithms, functors, and iterators. Containers are basically data storage. Data storage. It has objects and data. There are four types of containers: sequence containers, container adapters, associative containers, unordered associative containers. Then there are algorithms, as I mentioned before. This usually operates on the containers, and we can perform a lot of operations on them. Then there's functors. So it's basically function call operator, and it allows us to customize with parameters. Then there's iterators. Iterators is like a special kind of pointers to iterate through the containers or access various elements in it. Okay, so I'll move on. So we'll look at the types of containers in a rough diagram. So associative containers usually have uh, data structures that can be quickly searched, usually O log and complexity. Then container adapters are usually different interface for sequential adapt containers. Sequential containers, as we have been familiarized with them before, they're like arrays or vectors which have a particular sequence. So yeah, so sequence containers includes deque and list and priority queue. Ordered containers includes array, vectors, map, set, multimap. I'll share these slides later and you can have a look at it. This is basically the map to decide which container you want to use for your particular operation. As you can see here, this is just for information. You can refer to it later. It has different uh, yes or no, if else things where you can quickly check which kind of container might best suit your use. So now we will look in brief about the implementation of vectors and how we can go into the depth of how it works. So vectors, as you know, are dynamic arrays. They have contiguous storage, meaning the data is stored in continuous memory locations. Insert at the end takes different time, and delete at the end takes constant time. So as you can see here, this is a standard code for implementing a vector. So g1.pushback. Pushback is a function which helps us add elements in the vector. This here is an iterator. We'll come back to it later. But basically, we iterate through the vector to print whatever is inside the vector. So we'll come back to iterators later, and you can see the output of the code is here. So we will now look at how vector is implemented. So we discussed about templates, right? So we will use template to define a class vector because we want it to be used for different types of data types. So this is the standard declaration of the class, and we will define an array. So this is actually a pointer to the array, but this is our main storage pointer, which will point to the storage area. We'll define capacity and current storage as our variables. Uh, so capacity will indicate how much the size of the array can be at that moment, and current storage will indicate how much it is at the moment. So this here is a constructor. We are assigning new memory to our pointer using our pointer using the uh, new. So this is the function pushback, which we discussed before. It helps us add an element to the back of the vector. So basically, now what do we require for adding anything to a container? So we have to first check whether we have enough space to add anything to the container. So we'll check that here. If current storage is equal to the capacity, the current maximum size of the array, then we cannot add anything because that would give us an error. It will just overflow. So we have to first increase the capacity of the array, which we will do here. So we will multiply the capacity by 2, and then we will declare a new pointer, and using the new uh, keyword, we will have another array with twice the number of elements than the previous array. And then we will again we'll copy this array that we have to the new array that we have made using this for loop, and then we'll delete the previous array because we don't want any previous elements in it. And then we would assign the new array to, so we would have our previous pointer point to the new array by this. Now we already know the current storage, and then we would access that and add it here in this. So basically, if all if the current storage was not equal to the capacity, then we can still add. So basically here we have just added a additional step to check if the current storage is equal to its capacity. So after adding, we'll just increase the current storage to keep track of how much the array has been utilized. And here we have the square bracket operator, which helps us access the various elements of the vector. So we will have to check if the parameter we are passing is inside the bound of the bound of the array. So if the parameter we enter is more than the current storage, then we would have to pass an error that is index out of bound. Else, if it's inside, then we would just simply return the uh, data which is at that position. So that's how we overload the square bracket operator. You can look at the syntax here. Now, we also have the size operator, size function. So basically, it will help us return the current size of the vector. Uh, so we just return the current storage, which represent the size of the vector. And this is the at function. It basically returns whatever is at that position. So basically, it's again accessing the elements similar to what's above. All this can be defined outside the vector class as well, but I have defined it inside just for simplicity. You can use other syntax to define it outside the class. So, question: why do we increase the size of the array, and what will happen if we don't? Uh, Here's the Slido link. You can check it. Yeah. So around 13 people have voted. I'll wait for 2 more minutes. Also, if you have any doubts, post it in the chat or post it on Slido. Okay, fine. So around 65% of you have voted the option B, error because accessing is wrong. So that's right. We cannot uh, access anything if we don't increase the size of the array, because uh, we will have an element overflow, and you cannot uh, properly access the data that you have entered, because it will just overwrite if we don't increase the size of the array. Okay, fine. So now we will look at the implementation of list. So list is so many of you have tried the first assignment for CodeCrafts, in that you had to implement a linked list. So basically, this is similar to that. Lists are a sequence container that allow non-contiguous memory allocation, and as compared to vector, it has slow traversal, but once a position has been found, insertion and deletion are quick, because we just have to enter the next node and previous node. We'll get back to it later. Normally, when we say a list, we talk about a doubly linked list. For implementing a singly linked list, we use a forward list. Here are a few basic functions that are used in STL containers. We'll quickly run through them. Front returns the value of the first element in the list. Back returns the last element in the list. Push front adds an element to the beginning of the list. Push back adds to the end of the list. Similarly, pop removes the element. Insert inserts a new element at the specified position, uh, which is a parameter. And size returns the number of elements in the list. Okay, so here you can see this is a small code for a list. And basically, again, here we have used an iterator. So that's why basically iterators makes things easy to iterate through STL containers. And here's the output for the program. Fine. Okay. So this here is a basic implementation of a list. So it's just a rough overview. We have a structure, uh, then we have nodes. Again, we have used templates for different data types. Then we have a class list, as we had defined before, class vector. Here's a constructor by which we will uh, initialize the head, tail, and size. This is the size function, which will return the size of the list. And these are the private variables, the head, the tail, and the size. So we will now look at the functions. Basically, we will look at insert. So we pass some data and the position where we want to insert as parameters. And we will now make a new node, because we want to insert something in the list. So basically, this line makes a new node. We increase the size because we are adding an element. And now is the special part. When we add an element, the next uh, the next element after the element to be added is the parameter that we have passed here. So it will add an element before the position you have specified. Now here we have just uh, checked that we are not making any errors while assigning the head, the tail, or we don't have make any errors while accessing the null pointer. If position, this syntax means that position is not pointing to a null space. Basically, we assign the of our uh, previous of our element to be added as positions previous. So we are moving the position forward and inserting our element behind. Okay. The rest uh, deals with the accessing of null pointer to avoid accessing the null pointer and having errors. You can look at this code. Basically, understanding what's being done is more important than the syntax currently. So have a look at the code, and I'll share the slides later and you can try it out yourself. This is the pushback function. Uh, Basically, it will add an element to the end. So it's just insert using the previous function, insert internal to something. We just pass 0, which is the end of the iterator. For push front, we pass it as e comma head, insert internal e comma head. Again, we are using this function that we had defined earlier to have another standard function that we use in vectors and other STL containers. Similarly, here this popback. Popback will simply remove the tail, and pop front will simply remove the head and assign a new head. So again, this is the remove internal function, which is similar to the insert internal function. You can have a look at it. And so basically, it again deals with whatever was in the assignment. You assign, you make copies of the current uh, current pointer and then delete it and assign it to something else. And this returns the head, this returns the tail, front and back. Okay, fine. So why do we need all these functions? Uh, you can check the Slido. Meanwhile, I'll just let you read through these functions. We'll stop the voting at 7:36. So you still have 3 minutes. You can still vote. Also, let me know in the chat if you are finding things to be too fast or if you're not understanding anything. I'll try to explain it again. Okay, fine. Yeah, so 14 of you have voted, and the majority vote is because we cannot access pointers. So that's right. Uh, when we define the structure, uh, all this data is private. Because of that, we need all these functions so that we can access elements in the list and perform functions on them. So now we will have a brief look at the implementation of an iterator. So we we have we define a new uh, iterator so object. Uh, so we have this select constructor. Uh, Basically, star operator helps us return the data at that position, and you can check these other functions as well. So basically, we have this class, and based on whatever we pass inside it, so the way we define an iterator defines which kind of functions it will use for that particular container. So these are the data types. Uh, Basically, it will use the list node star position. So it will use a pointer to the list node. Iterator begin will return the head. Iterator end will return the tail or zero, which is a null pointer. So this is a brief implementation of an iterator. Yeah, and this plus plus thing is very common for pointers, as we have seen before. It just increments the pointer by one. But since the memory is not contiguous in case of all containers, we have to overload it so that the same plus plus can be used for different kinds of containers. Similarly, we have overloaded minus minus as well. Okay. Uh, you can scan the attendance QR. Uh, I'll give you 2-3 minutes. Again, if you have any doubts, put it in the chat. Yeah, so I'll give you another minute, then we'll start. Okay. So now we'll have a quick overview of the different types of containers. We'll start with sets and multi-set. Again, all this code, it's not necessary for you to understand it right now. I've just added it so that you can try it out later yourself and kind of understand what's being done. So sets are associative containers. Uh, they have unique values. So whatever you store in it, it will only store one copy of whatever you're storing. Multisets, on the other hand, can have duplicate values. Usually, the elements in a set are sorted. Uh, as you can see here, we have inserted G, F, and G again. But when we output the set, we only have F and G. Each is occurring once, and it's in a sorted manner. So that's how sets are implemented. Usually they are implemented using binary search tree. Again, I have added this for just for reference. There is no need for understanding it right now, but you can have a look at it later. Maps. So maps are also an associative container where values are mapped from keys. So consider a kind of a function where whenever you enter a variable, it will give you some kind of data which is stored at a place. So here you can see uh, we have defined a map and the key value is 1 and it is storing 1. So basically it's like a key which leads you to a memory location to access whatever data you're storing. uh, so keys and values are stored in pairs in memory, and they are implemented by balanced binary tree. Multimaps is an extension where multiple elements can have same key. So this is a brief overview of map. You can read through the code. Map 1 is 1, map 2 is 2, map 3 is 3. And then when we access it using iterators, the key value is represented by the first and the value is represented by second. So basically you're accessing the star iterator dot second in the second case. So this is the output of the program. And yeah, this is also another type of insertion of elements in the map. Map, the key values are unique for map, but multi-maps can have multiple elements having the same key. Now we'll look at stack. Uh, Stacks are type of container adapters with last in first out type of working. A new element is added to the top and then removed from the same end. So basically, you have a box and you're adding things to it. But whenever you add, while removing, you have to remove the element that you added last. So stack is implemented using deck. This is the basic code for a stack. You can have a look at it. You use push to add elements to the stack. Whatever is added is at the top. So whatever is at the top is also removed first. So as you can see, here's the output of the program. Since 21 and 22 were added first, and then two other elements were added on top of it, and then the top elements were removed, only 22 and 21 are remaining, and it would be printed in the order from top to bottom. Queues. So queues are a type of container adapters that operate in first out type of arrangement. So basically, standard queues in school or in college, where the first person standing in line is the first one who gets out of the line. Uh, Elements are inserted at the back and deleted from the front. Uh, Queues use an encapsulated object of deck or list sequential container class as it is the underlying container. Here's the code for queues. Again, push is used to add elements, uh, and then there are different types of functions here. Swap, it just swaps the tool queues. Uh, so you can see the output of the program here. You can read through this later. Since we are short on time, I'll just skim through these topics. Priority queues. So it is a type of container adapter which is designed such that the first element is either the greatest or the smallest of the elements in the queue. So basically, it keeps things in a sorted order uh, according to the priority. Uh, it is the implementation of heap data structure, and they are built on top of the max heap and use an array or vector as an internal structure. You can go through the code for priority queue. Basically, if we use this array to generate a priority queue, the priority queue will store things as 10, 9, 8, 6, 4, 2. So it's in descending order. Deck. So double-ended queues are sequence containers with feature of expansion and contraction on both ends. So basically, you can add and remove elements on both sides. It's similar to vector, but the contiguous storage allocation may not be guaranteed. They are a special case of queues. Again, as we saw before, that you can add and remove elements from both ends. The functions for deck are similar to vector. So that's kind of obvious because it's you're just having a container from which you can remove elements from top and bottom. This is the code. You can refer to it later. So iterators. Uh, so iterator is like a pointer, like I mentioned before, that points to elements inside the container. Now we cannot use standard pointers again because things are not contiguous. So they are not stored in continuous memory spaces. So cannot just simply increase the pointer by one and go to another memory location which has an element in the same container. That's why we want some special kind of pointer which will help us access elements in the container the way we do using pointers for an array. So the basic operations like plus plus and star are overloaded so that we can just use them how we use regular pointers. Again, we use templates to satisfy all kinds of parameters. So this is a basic code for implementing pointers somehow. You overload the star operator, you overload the plus plus operator. You have an ordinary pointer, but you using these functions, you help create objects of this pointer to access different elements of the container. So iterators provide an elegant way to match appropriate algorithms with containers, and this helps increasing the efficiency of the code. You can think of an iterator as a cable, like the cable used to connect a computer and a printer. So, however, all the iterator types are not the same, because all the containers are not of the same type. So you need different kinds of iterators for different kinds of containers. So again, basically something like this. You have a container, you have iterator, and it helps you access elements and have different kinds of algorithms working on it. So these are the types of iterators. There's random access, there's bidirectional, forward, input, output. Again, this is just for information. You don't need to understand it right now. Just you need to know that random access is used for vectors and bidirectional is used for list. So whenever you define an iterator, you need to specify what kind of container it will be used for, because since the iterate we have overloaded the iterator, we need to have some kind of declaration of which kind of container it will operate on. Otherwise, the compiler won't know what kind of functions it needs to have to operate on the different container elements. So here we define a list of integers, define an iterator for this list of integers. And when we do this, STL automatically makes this iterator a bidirectional iterator because that's what a list requires. So somehow this all this helps us make things easy for us, and it also makes things efficient. An iterator to a vector or a deck is automatically created as a random access iterator. This automatic selection process is implemented by causing an iterator class for a specific container to be derived, inherited from a more general iterator class that's appropriate to a specific container. So this is a major application of inheritance. Again, this is a visual representation of what an iterator does. Now we will have a look at few of the algorithms. Functors is also there, but it was covered in a previous session, so I won't be covering it today. STL algorithms perform operations on collections of data. These algorithms were designed to work with STL containers. But one of the nice things about them is that you can apply them to ordinary C++ arrays as well. So here I have shown you the find algorithm. It's basically helps us find elements. So the find algorithm looks for the first element in a container that has a specified value. As you can see the code below, you have to include the algorithm library for this. So yeah, so here we pass the beginning of the array, the end of the array, and the element that we want to find. And it will return the pointer to the first occurrence of this element. Okay, so we will have this offset 2. So basically, if you call this 0, this is 1, this is 2. So when we print it, we will have offset of 2. So yeah, this is the find algorithm. It basically makes things very efficient, and you don't have to write the algorithm for the code for finding elements again and again, because you already have an efficient way of finding the first occurrence. So another algorithm is the count algorithm. It counts how many elements in a container have a specified value. So you pass the beginning, the end, and the element that you want to count. And basically it will find the elements which have the value 33 and return the number of time it occurs. The output is 3. The sort algorithm. So it's one of the most useful algorithms. You will have a lot of use of it while dealing with different kinds of uh, containers, because again you will have other algorithms like binary search, which requires sorted arrays or sorted containers. So basically it will just arrange the elements in ascending or descending order based on whatever you uh, pass here. So if you want to make it reverse sorted, you have to pass greater, uh, the greater function. I'll add this at the end of the slides later. You can go through it. Basically, if we add something in this declaration, we can get a sorted array with descending elements as well. So this is the search algorithm. Uh, Again, this algorithm is very efficient, but we as users don't need to know how it works. We can just use it and believe that it is an efficient way of searching for whatever we want. So again, you pass whatever you want to search, and it will return the pointer to after using the function. Okay. So the merge algorithm. So Uh, this works with three containers. So it merges elements from two source containers into a destination container. Basically, if you have two sorted arrays, then when you merge it, you get a single sorted array as given below. Uh, Again, you can specify how much you want to merge using the parameters used in the function. So here SRC1, SRC1 plus 5. So it includes all elements in this. SRC2 and SRC2 plus 3. It includes all elements in this. And it also passes a destination which is an array uh, which stores the sorted array after the merge algorithm has been performed. So when you print destination array, you get this container destination container which looks like this. Okay guys, so that's it. There are again many types of different algorithms available. You can have a look at it online. Again, there's a lot of information available online, so you can have a look at the syntax and get yourself familiar with them. STL is very useful and it makes things very fast and efficient. So if you are comfortable with it, you can pretty much make yourself faster and code better. So here's the attendance QR again and the feedback QR. Uh, Also, please vote on Slido how the session was. Uh, the link is in the chat. Yes, the attendance form is the same. If you have filled it once, then it's enough. I've added the links to the chat. You can access them if you don't have the QR. If you have any doubts, post them on chat. If not, you guys can leave. I'll stay here for another 5 minutes and then we'll end the meeting.